Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, my name is Robi Septian from Universitas 11 Maret, Department of Electrical Engineering. Here I want to make a short presentation about my paper with the title is Design and Analysis of Monitoring System of Ozone-Producing Plasma Corona Discharge as a Disinfectant. This paper is written by me, Robi Septian, Miftahul Anwar, M. Maulana Yusuf, Rizky Ramakusuma, Teguh Indra Saraswati, Mayanto Eko Sulistyo, Ferry Adrianto, and Fandi Surya Adinata. This presentation is divided into 5 parts. I will start with the introduction, then the system design based on microcontroller, then the system control using human-machine interface or HMI, and then the result and discussion, and the final is conclusion. The introduction. As we know, COVID-19 is a global pandemic. According to the World Health Organization website, more than 200 million confirmed cases in the world. And we can see that on September 6, more than 4 million new cases has been confirmed, and total death more than 4 million people. That's why the disinfection is very important right now. We all know the use of disinfectant liquid is considered quite effective in killing the virus, but excessive use of disinfectant has the potential to be harmful to human health and the environment. One of this research refers to Mark Zuerman in 2020 by making of an ozone-based disinfectant chamber as a substitute of chemical liquid disinfectant equipped with a mist maker with timer-based activation for 30 seconds, but does not have an ozone concentration monitor, and the device cannot control the amount of ozone concentration to be produced. However, ozone in high concentration will also have a negative impact on the surrounding environment, including to humans. So this work will propose design and analysis of monitoring system of ozone-producing plasma corona discharge as a disinfectant. The novelty in this research is ozone concentration can be controlled and monitored directly through the HMI, so it increases the effectiveness and safe to use. Next, the system design. The hardware is assembled using 3.5-inch Next-in TFT LCD, which is integrated with the Arduino Mega 2560. This monitoring system is planned to be integrated with controlling device and ozone concentration. So to support the system, the data that needs to be measured are current data, voltage data, power data, air and plasma temperature, humidity, and ozone concentration. To measure this data, supporting sensors are used including PCLEM OO40 sensor used to measure current, voltage, and power input, MQ131 sensor used to measure ozone concentration, DST22 sensor used to measure the temperature and humidity of the air in the device, MLX90614 sensor used to measure the plasma plate temperature on ozone generator. And this is the schematic electrical circuit that it was designed. This is the ozone generator, dual sensor, HMI fan, ozone output, and this all system we put into acrylic box with size of 40 by 30 by 25 centimeter. Next, the system control. Well, we can turn off the appliance by plugging it into 220 volt source. Then the microcontroller reads the sensor value and sends to HMI. We can choose the mode from the HMI. There are 3 modes: manual mode, timer mode, and auto mode. On the manual mode, when we press on, generator on, and when we press off, generator off. This is the HMI main display design. When this is the on button and this is the off button. Next, the timer mode. In the timer mode, we need to input the timer first from the keypad. This is the keypad, and then we need to press the set timer and generator on. And when the timer is done, generator off. And then the auto mode. This auto mode, we use a feedback from MQ131 sensor, which is the ozone concentration sensor, and we press when we press the auto mode button, the generator on, and when ozone concentration more than 1 ppm, the system will set the timer for 60 minutes automatically, and we get into on-off switch control method, which is if ozone concentration more than 1.3 ppm, generator will off, and then when ozone concentration under 1.1 ppm, generator will on again. This will repeat until the timer finish and the generator off, and when the ozone concentration under 0.1 ppm buzzer will rings that indicate the room is ready to use. The use of 1 ppm of ozone concentration for 60 minutes is based on paper by Grigani et al. In 2020. And this is the HMI graphic display design. There is consists ozone concentration in ppm and temperature in degrees Celsius. Next, the result and discussion. The variable of accuracy and precision testing are voltaic, current, generator temperature, ambient temperature in the box, humidity in the box, and ozone concentration. Each measurement was carried out 10 times. In the accuracy test, the average total error is 2.62%. In the precision test, the mean relative standard deviation, or MRSD, is 1.43%. Hence, the final test result obtained an accuracy rate of 97.37% and a precision level of 98.56%. This test carried out in a room of 1.2 by 1.5 by 2.5 meters. And on a voltaic and current graphic, we can see that it's quite stable after 7 minutes of activation, with the value was 280 volt and 0.46 ampere. And the ozone concentration is getting stable for 1 minute of activation. And the temperature, the red line is generator temperature, which was the maximum of temperature of generator temperature was 96 degrees Celsius, and the maximum ambient temperature was 39 degrees Celsius. And the humidity was dropped from 81% to 68%. And then this picture is captured by thermal camera FLIR 1 Pro. When the generator started, we can see that the plate still at the room temperature, which was 32 degrees Celsius, and after 1 minute of activation, the temperature increased to 56 degrees Celsius, and after 10 minutes of activation, the ceramic plate was hot. They'll be marked with bright yellow color, with and the temperature was 96 degrees Celsius. And this is the top view of the appliance. This is the HMI, the ozone generator. The system control consists Arduino, relay, SD card module, and other sensor. And this is a buzzer and MQ131 sensor, or ozone concentration sensor. This is the fan to blow the wind to the exhaust. This edition of fan is very effective in lowering the temperature in the generator circuit and also around the generator for 25.6% to prevent the component around the generator from the damage. And the last is conclusion. The spread of COVID-19 can be prevented. The system is designed in public place, especially room, easy to use, easy to control and monitor. Based on the result, this appliance is suitable for use. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.